Mohsen, I made friends with Mohsen's supervisor, Samad Beneathi. Then he told me he had this great student who wants to come and finishing a PhD, wants to come work with me. So Samad's in Iran. And then the student appeared at the IMPC in Brisbane and gave a fantastic presentation and made very sure that he got hold of me. Anyway, so I offered Mohsen a job. And you'll have to remind me of the year, Mohsen, that you came.
2011.
11, okay. So it's 12 years already, sure. Coming up 12 years. And so Mohsen really proved himself fantastic. He was mature. He had worked, done a PhD, was supervising students back in Iran, and continued to do remotely. And so gradually, as Mohsen developed in that role, he gave me the opportunity to step back. And so I stepped out slowly sideways from leading the Comminution group and moved Mohsen forward. And I stepped out and he took over. And then 2 years later, he became the director of the JKMRC. So I escaped in time, Mohsen. So been a great journey together. Still
Yes.
work really closely together. And it's been a real, one of my best decisions ever was to take up the opportunity of employing Mohsen. And now he's director of the JKMRC, but it's still running the program around autonomous systems. And then I was in Peru presenting a workshop, and then we had Comminution in Peru, and Mohsen gave this fantastic presentation, most forcefully in front of all these Peruvians who were getting translated to in Spanish. And I said to him, please come and give it to the GCC. It needs a wider audience. Very nicely researched and a broad background. So that's how come Mohsen landed here. So I'd really like you to welcome Mohsen. You can add anything else you want yourself to your background, Mohsen, that I've left out.
Yeah, thank you very much, Malcolm. Yeah, I think that was everything. And it was very, to me, one of the key point for me was actually selecting my supervisors very carefully to make sure that actually I learned a lot from them. And I think certainly you were one of the ones who actually is a very top person. So, and I think I should basically attribute some of the work that is happening and what we have done definitely is attributed to you as well, with your leadership and your contribution to the center, definitely. And it was very good. So I'm very glad actually I'm here, and thanks for the invite, and thanks for the GCC members to give me the opportunity, and also for everybody joining. I'm hoping that actually I share some of the ideas and you find it useful and you use your time. As Malcolm mentioned, and as you can see, I decided actually not to change the template to make sure that actually it's clear that actually this one has been done before. We gave it to Comminution 2002 in Peru. But as Malcolm mentioned, I think it's fair to present it to a wider audience. If some of you have been in that event and you watched it, so my apologies. But normally when I talk to this, always it comes to a different version. So probably you're going to hear me saying something else now when I'm presenting. So you won't get bored as much. So I think as Malcolm mentioned, like when I was working still with Malcolm around 2015, 2017, I started building that idea that actually we have to look into automation and process control as well. And at the time, because of the changes, we agreed that actually I can start developing a group that actually looks into process automation in JKMRC. And I think many of you that you know the history of JKMRC, you know that actually the whole center, actually when Albin Lynch established it, the idea was actually around process control. So his vision was actually to use computer programming and mathematical modeling to understand the process and control it. And then over the time, essentially the direction moved into developing mathematical models, software packages, optimization, and essentially looking into those approach. But I thought that actually now it's the right time with the direction that the industry is taking, and we are moving to that direction. And also the very strong background that we have developed the partnerships that we had with different groups, especially like the GCC members that actually they have been working in this space in dynamic modeling and control. It's the right time that we start stepping into this space and kind of leveraging that background and history to deliver and offer something to the industry that actually is going to be transformative. I mean, my master's degree that I've been working in Sacheshmeh, was one of the copper processing plant, actually set me to that direction as well, because when I was doing my master's, I had to design a column flotation in a pilot scale. But to me, what I found was actually the design of that column flotation using equations that was in a book that James Finch published wasn't the hardest part. The hardest part was actually get that froth level and the pump working together to be able to stabilize the froth. And from there, I developed a passion around process control and automation. And I think I'm leveraging some of that experience over the time as well in this work. And my vision, I mean, probably not my vision, the whole team that are working with me, the vision that we have is essentially about, can we essentially move toward automation of mineral processing plants as well? And I will explain in a moment why, and what are the opportunities and why basically, and what are the challenges. So maybe I don't need really to go into JKMRC, but I thought actually it's good opportunity for me to market a little bit for JKMRC as a center director now. But many of you guys have long association with JKMRC, and I know that actually I mean, that partnership has been very valuable for all of us, certainly. And just a quick overview, because we had lots of changes and kind of adjusted our direction. I thought actually this is a good opportunity with a large number of audience to share where we are moving ahead and what's our passion at the moment. So, I mean, one of the key areas that we are moving very strong, and we would like JKMRC to be known about it, is essentially our focus on transformational technologies around mineral processing. So we are looking into how we can actually come with a new way of thinking in development of the process units, or identifying process units that they are transformational and helping to de-risk them and make them available for uptake, and also changing the way that we thinking about how the operation should be formed together, configured together, and operate. So those are, to me, are the ideas that we are looking into, that in terms of it can transform the mineral processing processes. And we kind of started building skill set and capabilities that we require, whether it's within the center or through the partnership that we have with different groups. And at the moment, we got 5 different domain expert groups in our JK. 2 groups pretty much focused on separation. One of them is we call non separation technologies. So it's not only flotation. We are looking into like high voltage pulse as pre-concentration techniques, coarse and fine flotation, which is the strength of JK as well. And now looking into other opportunities in that space, especially around comminution, classification as well. The group that we have around surface chemistry, also they're looking into how you can actually transform the chemistry of mineral surface. In fact, they are thinking actually changing their name into minerals chemistry manipulation. Essentially, we want to use new type of reagents, new understanding of the surface of the mineral, and manipulate them in a form that actually we have more freedom to interact with them. And recently, like over the past 3 years ago, we have essentially heritage the group from chemical engineering that they are focused on pyrometallurgy as well. And I always thought that actually JK is lacking that part, because whatever we do in processing, it's important to have capability in terms of what's happened with the concentrate. And we might be able to actually affect, or in fact, impact each other as well. So we got now a group in high temperature processing that they're part of the team. They're pretty much working into novel ways of smelting materials using different techniques, which is primarily around green smelting, green steel, green copper, and base metals, and they're working in that space. Even around transformation of the waste material, that's one of the areas that we are working. And then obviously the group that I worked with the team and developed it for over the past 5-6 years around process automation that actually works in that space. And other area that we have been strongly focused since a few years back, we didn't move as basically fast as we would like, but this year we actually managed to bring some new blood to that group, and we are moving very fast in that space as well, is energy transformation, transition and integration, which is around evaluation of essentially carbon footprint and energy usage of different processing pathways, and how you can actually facilitate transition from hydrocarbon-based energy to mineral-based energy or renewable energy that people they call it. So that's essentially how we are working. It's very, I don't think it's unfamiliar to many of you guys that you're working in GCC as well. So pretty much the model is you go to the industry, offer a solution that actually you developed it over the years, and through that we collect data and also get funding that you require to develop the future solution, and we can offer that over and over. And at the same time, we are basically focused on some of the fundamental research. We have been very lucky to get a large amount of funding from the government, which is the Australian Research Council, collaboration with multiple universities in Australia, and that gives us opportunity to actually go at the very fundamental level as well. But still we keep that high practical capability by working with and partnering with industries as well. And that's essentially how we are working. Some of the key point for me is whatever I present today, I mean, normally I get basically the pleasure to present it, and normally people, they see, okay, this guy is presenting it, but it in fact actually is what I'm talking about it's enabled and driven by a large group of people. So these are the leadership group at the moment in JKMRC that they are basically helping me with that direction. Associate Professor Lisa Forbes, Associate Professor Kim Rangi, and Dr. Jiadong Ma. And each of them, they are leading those research groups, and also they running those programs. And then the help of all of these research teams. So obviously you can probably recognize Malcolm and team that actually I always benefit from their support and their mentorship. But we've got a huge group of people that they are working in this space. And I think the brilliance in the research actually helped me to formulate these ideas and put them together. So I would like actually to attribute some of the work that I'm presenting today to these people, and not to forget the students, because I think I always have a passion about the students, and I always talk to them and I say, you are the main driver of our research, because you are the people actually, you have enough courage, enough time to start breaking the boundaries and get out of the comfort zone and deliver things that actually we always dreamed of, but we didn't have time, or we didn't manage to go through that level. And you can do that, and you're doing it that as well. So, and I'm pretty sure again, many of our colleagues that actually are in the talk, they feel the same way, because they are essentially about supervising and training PhD students. And I think some of the work I'm going to show, not all of the students that they are here actually, I mean, like Zeeming Ye, that actually some of the work that I'm presenting is his work. Now already is in industry, and he's not part of this picture now, but those are students that they are past as well. They had contribution. So, I mean, enough of the background, but I think the idea and why automation piece and why we are thinking about automation, I think it's important. I mean, all of us, I think we agree that actually one of the big driver in the industry at the moment, and from the past and still, is NPV, net present value. So everybody wants to make sure that actually they get the maximum return on their cash spend as soon as possible. And every project and any work that you do, any mining activity that you do, is basically assessed by that NPV. So you want to make sure that you got maximum NPV around the whole life of the mine. So that's a big driver. You can't actually really deny it. I know that many people in this call, they don't like it. I'm one of those ones as well. And we think actually it's a wrong measure. We have to change it. But this is something that is happening. But I can see a strong move as well. So if you look at the moment, I mean, 10 years ago, probably, that drive in terms of the NPV and the financial gain is everything about the business, but there are things that you can compromise because of the finance. And safety was one of those ones. Essentially, it was a big drive in the industry to make sure that this is a very safe essentially industry, and you minimize the safety basically dangers that you create. even if you have to compromise on your financial situation. And that's one of the big drivers. Now, over the past 5 or 6 years, all of us, we have been hearing about environmental, social, and governance, or ESG, or the UN Sustainable Development Goals. That actually is a big drive towards sustainability, and it's a big push for the companies to essentially demonstrate that they are performing in that level as well. So that means actually, although we have been running toward a maximum NPV, but that maximization of the NPV has to happen within a framework which includes those safety aspects and your contribution to the sustainability of the society as well. And to me, if that's the case, then what's going to happen is essentially we have to perform at much lower cost with much higher productivity, with the emphasis that we have on our sustainability aspect as well. So essentially, that's one of the biggest driver for the operations and for our basically mining operation. Especially at the moment, this pressure is even higher because of the energy transition and that social aspect that exists with mining activity. So that's how we need to operate. So this is the kind of environment that the business is operating. In my opinion, after a long time that I've been engaging and talking with people and discussing in terms of how we can actually make mining to operate more efficiently and do that, I think I come to the conclusion at the end that actually it is all about the decision-making process. So the decision that we make in the mining and how we can make coherent decisions across the whole enterprise. I think that's the biggest part that actually, if we can unlock and we can solve it, is going to actually address those issues that we are talking in terms of managing and contributing to the sustainability of the society while we are maintaining that economic, the business economic as well. So, and I think all of us can give hundreds of examples that actually those decision-making are not coherent, and at different level, you have different basically directions, different criterias, and you make decisions based on different type of information, and in many cases, they are not very coherent. And our argument is essentially, if we want to go to that path of sustainability, the coherent decision-making across the enterprise is very important. And to be able to achieve that, it is important to make sure that the information that you need to provide for decision-making is provided within the time span of discretion. This is a term that I borrowed from my education from MBA, which I found it fascinating because it gave me lots of view, and I'm going to explain it in a moment, okay? But keep that word in mind, and I will explain it. If that information provided in that time span of discretion, that's actually where that information becomes effective and efficient, and you can use it properly. If those information are coming outside that time span of discretion, although you provided it, it's not useful, or you're not going to be able to make decisions that probably is going to be coherent with other ones. And being a person that is fascinated with technology, I think actually technology can enable us to be able to deliver those information within the time span of discretion and help to facilitate coherent decision making. So that's essentially my argument. In terms of the current status, if you look at, so you will see, and I think this is very, very familiar for many of us that have been working in operations, and I call it, it's very hard to sustain the improvement that we made. So I can see all of you guys, I think I can name all of you by name that actually have done all of these work. So you go to site, you offer a very fantastic solution, very well taught, you implement it, it works, and you show the value of that work, you train people even, and then you walk away, come back in a year or so, everything disappears, and you have to repeat the whole process. So that intervention that you have done, you provided a very well advanced solution, and it's implemented, it demonstrated this value, but it's not working. So, and I think mine to meal is a typical example that it has like an average life cycle of 2 years. So, and many consultants actually, they earn their money from this process. And probably if you are moving to that direction, probably they don't want us to give this presentation a lot because we're going to block their business. But you go there, you do the basically the mine-to-mill optimization. 2 years later, either you or somebody else has to come back and do the same thing. The same happens with the technology as well. So it's very hard to get the technology to work as well. So this is the example that I got from my colleague, Professor Ross McCurry from mining and mechanical engineering. I have a very close partnership with him over this automation piece because he has a very long experience in autonomous dozers and autonomous trucks. And that example that come from him was actually about the collision avoidance technologies. So a very well advanced technology, it's proved that actually has capability to deliver value, increase the safety, easy to implement as well. You implement it, and then after a while, for many, many reasons, it just stops working and you have to just basically abandon it. And that happens over and over with different technologies. And I think in mineral processing also we can give that basically examples for many times. So although basically the technology can work, but again, there are issues that we have to solve so to be able to make it actually to be sustained. And I think it's all come down to, can you make that technology to provide effective decision-making support? Because that's the key part. If they contribute to that coherent decision making, then that's where people, they want them to operate because they contribute to that decision making, and that's where they make sure that those technologies, they're going to work as well. So, and I think that's very it's an important part of the process. So this graph actually is where I'm going to discuss about the time span of discretion. So I mean, this is a typical, you just drew it in one afternoon. So just looking into horizontally into what are these processes in the mining. And I just did a very high level view in terms of, you start with exploration and mine planning, then you go to drill and blast, then you do extraction and loading, the processing, and then you go to market. So that's pretty much in a simplified form is what the activities happen. And that's where the decision that you make is going to have an impact. That's essentially, it's the area where the effect of those decisions affects the process. And then that's where you're going to see the consequences of the decision has been made and the results. But where those decisions are made and how those decisions are made is where it happens in the vertical level. So you got the first level that they are operators that actually they have to play very close with those processes, manipulate them and control them. Then you got the upper level that we call them production managers, people that they provide guidelines, they give them essentially limitations and all of that. And then you got the unit or plant managers that generally they give production targets, they have to allocate resources. And then you go higher up the chain, those people that actually they kind of decide on the direction of the company and the future directions as well. And essentially, if you go from the bottom to the top, the time that you have available for within that frame to make critical decision is increased from the bottom to the top. And that time is called time span of discretion. Is the time that you have at your discretion to make the decision. And that time changes as you go from the operator level to the high level, okay? But one of the key points that I wanted to grab your attention to this graph as well is about the distribution of the decision-making process. So you have multiple points at different levels that they have to make those critical decisions. And I just started looking to how the flow of information happens and the flow of the data with the green and blue and essentially purple one, which is about like a critical or at the corporate level information and decision that comes in, the managerial or operational level, and also the data that comes from operation. You'll find actually it's quite complicated process, and not all of the data comes to the people at the right time. The decisions are quite distributed across the process as well. And that's one of the, I think, one of the features of our mining organization. The other thing that I've done, I said, okay, let me just visualize the time span that people they have for making decision versus the number of people that they are in that organization that they have to make decision within that time span. And that came pretty much like this graph. So if you, I mean, this is kind of a scale based on some of the organization, but if you pretty much go and get some data and put it there, you're going to probably come very close to this graph. That actually you got the highest number of people that they work at the operation level, then you got superintendents, managers, general managers, and then you got your operating officers and CEO, or hopefully if your company is a good company, then probably you have only one. But look at the time span that they have. So essentially, some of the operators generally, they cannot make decision more than, like the time span is not more than minutes. So you got seconds or minutes to make decisions. Should I close this valve or open it? Should I run this pump or not? Should I send this truck somewhere or here? You don't have hours and hours. You have few minutes or seconds. If you're lucky, you got some minutes. Then if you go to the people that they are kind of superintendent, usually they got hours as well, or days even, to make decision. And that time span of discretion goes higher and higher. People, they make decision over weeks or even sometimes years to make that decision that they want to do. Especially if you go higher level, you got that much longer time span for making decision. So that's one side. But if I add a second side, which is about the volume of information that is available. And here, I think many of you guys understand what I'm saying, information, not data. So obviously the data, if you got the operation, you got huge amount of data. But if you think about information, then yes, the person who's sitting at the CEO level pretty much has all the information from the company, and at his or her own discretion, they can actually make it available and use it. But if you go down to operator level, there are minimum amount of information that you have, and you have to make critical decision at that time span. So many critical decisions, essentially, you make it in the time span of minutes with the minimum amount of information. And actually, those are decisions that actually has huge impact in your process. How coherent and how consistent are those decision making? So again, many of us have been in control rooms. We understand even when two shifts they change, the whole control approach changes. It's highly dependent on preferences of the people as well. So that's not a coherent or cohesive decision making as well. And let alone that the person has to make decision without having even enough information. So they have to make lots of guesses, there are lots of interpretation of some of the data. Always they have in their mind some myths or some ideas in terms of how things are working, and they use that as a rationale to make decisions, which is not really proven as well. So how do we make this decision making better? I think obviously if you start flowing more information down the chain, it's going to make it better. But at the same time, I think changing and trying to automate as much as possible those decision making that happens in the order of seconds and minutes. That's going to be very valuable as well. And I think this is a kind of my dream organizational chart, that actually you push most of the people at the operator level to what I call them constraint managers. So you make them people that they look after constraints of the process and try to debottleneck the process rather than sitting and doing boring jobs. And now actually this week, I heard it 3 times from different people that they say people who are working in remote operation centers, they don't like their job, and the turnover of the job actually is very high now, especially like in Perth and Brisbane. People that they work in remote operation centers, they work for a while and just they quit and they go to another job because they don't like this type of job. And to me, the reason is you put them where that actually the human intellect is basically not used at all. So they have to sit there, open the valve, close the valve, and do this, do that. And that's it. The decision making that actually can be automated very well. But actually, we could get them and challenge them and use their intuition to identify actually at a strategic level, what are the bottlenecks of the process? What are the constraints of the process? How you would mobilize your resources to release those bottlenecks. That's where the human being actually thinks very well, and they can actually perform very well. There has been lots of attempts. People, they use machine learning and AI technique to work at that level. And to me, I can see very clearly that paradigm shift from industry 4.0 to industry 5.0, which we initially have been thinking, trying to replacing human with machine, and AI, but that paradigm started shifting because we know that actually many of the decisions that we make are very complex. And you need huge amounts of information to be able to train an AI. And also you need to constrain it significantly to make sure that no mistake happens. And I will explain it in a moment, because if you give automation to somebody, then the expectation of the people from those autonomous systems is much higher than human. So therefore, it's very expensive to develop them. And often people, they don't trust to use them as well. But if you combine human being with those systems and give machines a low-level decision-making, which they can do it very efficiently, and also give them lots of that. They can do many of those much faster, much easier, and more consistent and coherent. And then human, with his intuition, can start focusing on identifying where are the constraints. How do I mobilize things to release the constraint? So then my automated system at the operation level can perform much faster and better. That's essentially how I'm seeing that actually organization is going to work. And hopefully with the help of the automation, because automation provides data, which essentially is going to be very valuable. And also we can use later with tools that we have developed, and we can share some of those. We're going to share some of those to transform those data to useful information. Then actually we can start increasing the amount of information that is available as well, and let people to make decisions at that time span of discretion that they have. And hopefully if you do that way, we can actually simplify the organizational structure and the decision-making structure as well, because many of the critical decisions that you need to make in a time span of very short time, it can be done automatically. And then you got people that they are constraint managers. They look into the constraint of the process and they can solve that problem as well. So obviously, when we're talking automation, we have different perception of what automation means. I've talked with people when I say I'm working on autonomy and I want to help you to automate your process. They say, our process is automated. I say, okay, really? Yeah. And then you say, okay, what do you have? You say, oh, but all of these PID control, they work. Okay, that's not the level of automation that I'm talking, because that's essentially primarily is in your semi-autonomous systems that actually you have. So we have to be clear when we are talking about autonomy and automation. What do we mean? This is one of the framework that we essentially borrowed from. That's primarily borrowed from autonomous vehicles, and then Global Mining Group also adapted it. So you got different levels. There are many versions of these ones, but I think this one is one that actually I like the most. So you start from no automation, which means everything is done manual. Human has to make decision, move things around, to fully autonomous, which means actually even for those constraints, you don't require human and they are not there. I don't think personally that that's going to be happening in the near future, but we can actually get human being to be involved that, but we can get at least to a highly automated system that actually most of the automation part decision making is done automated, and human can work in that space. I think if we look and be fair, probably mining is sitting between level 1 and level 2. So mining is a little bit advanced of processing, but we are in general in level 1 and level 2. Although I think some of the mining companies, they like that actually they would like to think that actually they are much ahead. But to be honest, I've done many work with some of these big ones and the small ones. I don't think anybody passes level 2 more than level 2. But the target obviously is level 5. So we want to move that down. So, yes, there are many autonomous systems and technologies are in mining already. People, they're using them. And that's one of the things actually I try to take side of the mining companies when people, they say, no, mining is very old fashioned. They are not basically innovative people. I say, I don't believe you, because I can see some of these examples, but at the same time, we shouldn't think about, okay, if you got an autonomous truck, therefore we are in level 5 or 6. Autonomous automation level actually has definition. We have to look into that. But there are many examples. So from trains that they're running, or autonomous trucks, to even robots that now they are used in lab, or most of the underground mines, actually, normally you don't have basically human down there operating equipments. All of them are done remotely or automated. Drones are heavily used, especially the ones that actually they do autopilot. So we have lots of stuff that's happening at the moment over the past 25 years, let's say, and has lots of benefits as well. We improve the safety, we improve the productivity, The maintenance has improved. We are working toward emission as well. So therefore, it's happening in that space. But the argument that we have is actually we are lagging. Excuse me. We are lagging that level in mineral processing. So there is a big push over the past few years. We have been seeing that people, they want to move toward advanced control, model predictive control. Our colleagues in Chalmers, they have been working in that space, especially around the crusher plants. But we don't see that level of automation across the whole mineral processing plant. And that's essentially one of the issues that we see. Although most of the plants are very well instrumented, we collect lots of data, but still we are basically lagging, and we need supervision, and most of the manuals functionalities are manual. Even in control rooms, that they kind of forced to run in automated mode. What I found fascinating is essentially how human being actually his mind works, and how they can find way actually to drive the way that they like it. So I was in one of the operations, I wouldn't name them, and they had these KPI that they measured the number of hours that each of the processes was in auto mode. So that was one of their KPI. And what was basically the trick of the operators to get around that and run the plant still manually? They put it in automated, but they set the boundaries of the control exactly within the limit that they want. So essentially they drive the control very manually. So still we are not doing it. And I think those groups, I don't blame them, because when I talk to them, I realize actually they don't trust that system. And that's, I think, what I found is the problem. So the key issue actually is around reliability and trust. Most operators, even the managers, they don't trust to let the system to run autonomously, even at that lower level. So then they can start focusing and thinking about the higher level. And I think these are the three main criteria that I would put around the trust. So it has to work reliably with minimal intervention from human. So if you can trust that it works with minimum essentially intervention, that's where you start building trust. And I think when one of the key points, actually most of the technologies they are missing to deliver, is what's the rationale for the decision that system made? What's the logic behind that? Because us, the human that has to trust the system, they have to understand the logic behind that decision. And normally we fail that. And I think that's actually pronounced much bigger when you start moving toward that black box and AI machine learning, because there's no way to be able to understand the logic behind the decision that is made by those type of technologies. Although many of basically people that they are working in that space, they tend to think that actually, okay, we got all of these techniques that we can present to show the rules are behind the whole system, but still they cannot show that logic and to prove that actually the decision is safe. Then it's, as I said, it's the rationale behind the whole system. So we need to make sure that actually we can review those decisions, we can analyze them as well. And one of the beauty that actually my colleague, Professor Ross McCurry, has done for his dosers, autonomous dosers, one of the things that they do is every decision that is made, they provide the rationale to the supervisor, the human supervisor, because they need to make sure that the human is comfortable with the decision that has been made. So there is nothing basically hidden. And also the human being has to accept it. And I think that's human interfacing and human integration is the big part as well. And these are very complicated problems. It's not very simple and easy. And I think we have to work in that with many other groups. It's not only about us as engineers to come up with the solution and implement it. My point essentially from my two slides is about, this is a complex problem. So our approach, it shouldn't be only about, okay, I'm going to develop these models, develop these tools and make the system automated. There are many other things in that actually we have to involve people that is probably out of our skill set. But essentially that trust has to be engineered into our process. Then we can make sure that the system is going to work. So some of the issues that I would say exist. One of them, and the key one, is the human-machine relationship. If you like, I think this book is very interesting. If you haven't come across it, How Humans Judge Machines. And I've read it, and it's very fascinating work. They have done a very thorough, comprehensive survey of human beings with scenarios. I really enjoyed the way that they designed the scenario for collecting the data. And they proved that actually human treats machine differently compared to human, even if they make the same decision with the same data and the same circumstances. People, they expect more from machines. And that, I think, is very important when you design. And that was a number that they gave. This was actually machines, if like a decision is made by human, they can be up to 60% basically correct. And still people accept it. They say, okay, this is normal. You can make 40% mistakes and still they're happy with you. But that number for machines should be more than 80%. Then people say, yeah, that decision is fair and we don't have no problem. So this is a fascinating book to understand the complexity there. And I think it's very important. So as I said, the development starts with trust. And that trust has three elements as well. So it's people, it's process, and it's system. So we talked already about people. So people judge machines differently, judge automated system differently. So when you want to design that, you have to incorporate that view. The other part is about system, the data that you collect, the information that you provide to make decision. That also is very important as well. And again, this is one of the other books that I really enjoyed reading it. And in fact, we invited Andy to come to be a keynote in one of our streams, autonomy streams in World Mining Congress that happens this year. And I'm a co-chair on that one as well, talking about this one. So there is no point if we have rubbish data to put it into our autonomous systems and try to digitize everything, which is something that I can see over and over in industry happens. People, they don't have the basic level of data collection. They don't have basic level of accuracy or essentially validity of the data, but yet they move into essentially digital platforms, digital twins that they talk about it, and all of those things, which luckily now the buzzword now is different. So nobody cares about digital twin. Everybody talks about net zero. But that's the point. So, but to me, the data is very important, and it's very important to make sure that we trust that information. And if you look at the mining business, so that data, the flow of the data across the whole process, you generate huge of them. But how you would trust that, how you can make sure that those data is available and they are correct, they are reliable, you can trust that information. To me, that's essentially is very key. And how you would make sure the flow of the data throughout the whole process. Because if you look at the mine, you got several platforms, several areas that you collect the data, often disconnected, sitting in different groups with different formats. You can't actually even make sure that the data that you got from the ore can be tracked all the way to the processing. First, from the infrastructure. Second, there are areas that you can't really measure them, like stockpiles. That's one of the areas that I'm going to talk about in a moment. So you have all of these areas, these stockpiles. The moment you have your ore hit your stockpile, then you lose the track of that material. Although you might have a sophisticated model in your blast, you got your basically loading shovels that actually they have GPS, they measure the grade, size, and everything. But the moment you feed it to the stockpile, then you lost that information. That's one. And also, you got all of these different platforms that they sit together and they do that. So we are talking with some of the mining companies. One of the biggest effort at the moment is to get all of these several platforms that they have to talk to each other as well and make sure they can flow information in a form that the other platform can use it. So our focus actually, I think it should be looking into how we can cover those gaps. As I said, I mean, we are a research group, so we are not consultants. We are not here to develop a platform to offer that. Is our role essentially to understand if that's the vision, and if we agree that we want to move toward that automation, what are the gaps that that exist that if we address, we can make it to happen. And now I'm going to just focus very briefly with the time that I have to just go through some of the efforts that we made in terms of addressing some of the gaps, which I would love then to hear your ideas and also understand what you might have been doing so we can actually join our effort in there. I think one of the key areas that I'm looking very seriously is about transforming the data and extracting information from that. We know that we are generating huge amount of data, but the problem is we are not using them properly and you are not turning them into meaningful information. And I think one of the key points, which is this group that they are attending, like are in this room today, are well positioned for that, is people, they tend to ignore the domain expertise. They got all of these fancy tools. Nowadays, if you go online in YouTube, you can learn Python in a moment. And then you got a huge amount of Excel file or Power data that you collected from your plant. You just throw tools at it. And because you want to show your boss you're very brilliant, you're going to do all of these fancy things and say, look, I've done this Python and I got this relationship. Ignoring all of the relationships that exist or domain knowledge that exists. I think that's very important. There are many aspects into that data analytics. It's a very dangerous area. Now that I'm exposed and worked with one of my colleagues who is expert in this space, I started understanding more and more what are the pitfalls that we might fall into if we don't basically be careful about how we treat the data. But there are pathways. We can develop tools with collaboration between domain experts and data analytic people. We can actually extract lots of useful information. So we have been doing some of these works, especially around isolating data into basically clusters that actually now it's meaningful, and rather than lumping them together and try to see patterns that it doesn't exist at all. And you can see in this graph, probably it's very hard to see it, but essentially it was a practice that actually we got the data from a different ore type that has been fed to the plant and the response of flotation circuit to recovery. And initially we had a cloud of data, and it was interesting because one of the consultants tried to put some relationship there, which I couldn't see them, but it seems that his eye had some sort of X-ray, something to see those. And we couldn't see anything. Then we said, okay, let's start going properly. We did clean the data, remove many of the data. This data that you see is probably around, I think if I'm not wrong, it was around 2% of the overall data because 98% wasn't useful. And then we started looking into those different ore types. And it was fascinating to see that some of the ore types, they show a very strong relationship between size of the cyclone over PAT and the recovery. And some of them, they don't show any relationship. But when you put it all together, you're not going to see that. And so these are the key points. I think we have to look at it. And it's nothing new for many of the people in here, but I think we have to start making sure that people, they don't get into that pitfall of, okay, I got a tool, I'm going to use it. We have to start working together to make sure that analysis are done in a rational way. So then we can make meaningful information. Because from the data, you can pretty much get any conclusion that you like if you're not following the right path. You need to follow a right path to get a conclusion that is correct. So, and I think many of that part actually can be automated as well, because most of these pathways that we are generating at the moment, we are pretty much looking into workflows that actually then you can actually pretty much put the data and automate most of that, not fully, but at least you can do it to a certain extent. Soft sensor, I'm not going to talk too much about it because we have been talking about this a lot. And I think one of the key points that I want to mention here is we have to leverage, and this group in here actually, they are very strong in developing models that they are semi-fundamental or fundamental or even empirical. Still, they are fantastic models. People have been using them and we have been using them. Let's think differently, how we can actually transform them into tools that give us insight from operations or processes that is very hard to get it directly. And we can use it. Another application of the sub-sensor actually, which I'm now more and more interested about that aspect actually, is about reliability of the measurements and kind of stamping the quality of the data that is generated using sub-sensor. Imagine you got two sensors and you got a model that actually combines the data from these two sensors to make a calculation. And if you use that model to evaluate the accuracy of the data that you got, because the model, if it's based on like physics-based rule, let's say, for instance, you got the ultrasonic sensor and you got the pressure gauge. And now you know essentially the height of the liquid in your column. So you can actually use a physics-based to predict what will be the pressure. And then if you got the pressure reading as well, you can actually kind of quality stamp on that in terms of how accurate is that data based on the model as well. And that's what we have been trying to do with our mill fit, which is a mill filling inference tool as well, to use it as a kind of a cross validation of some of the hard sensors that people they use. And I think we are at the stage that actually we can pretty much develop many of these sub-sensors for the grinding circuit to give a very good insight in terms of what's happening, or even validate the measurements of those sensors that we have. The other area I think is dynamic modeling, which is important. And I think this one I'm very proud because it's a work that one of our PhD students, which is now we should call it Dr. Ziming Ye, have done it as part of his PhD. My colleague Marco has been heavily involved. Marco was one of the advisors that actually was giving him usually hard time with giving lots of ideas. But we developed a model that actually we thought it's a gap in the industry, especially around the material transport, and being able to manage the size segregation, where the material is going to end up in different locations, and how you would basically you can transform that information to the downstream. And I think one of the key points for me, because I can see in the when you read papers, I do a lot of that. People, they come with all of these fancy tools and interesting tools. One thing that always argue with those publications is lack of validation. Normally people, they've done it in a lab, not validated. And I think this is, again, a strength of the GCC group in terms of whatever we develop, we have access to lots of industry that actually we can validate the data. And this model, actually, I'm very proud because we validated it with an operation that I presented here. And my colleague Marco also implemented it to another operation, and we validated it as well there. And this is just the ultrasonic sensor data that was on top of the stockpile, which is the gray one. And the orange is what the model predicted exactly at that point. And the blue line is actually the highest height of that stockpile, which they couldn't measure it at the time because of the limitation of the sensor. And we could basically see that actually the model tracks very well the ultrasonic sensor, but at the same time can demonstrate that there is a gap in the measurement. Actually, the actual material inside the stockpile was different. Even size, which was very important for us, we tested it over 2 months operation. The blue line is what basically the split camera measured, and the orange is what we predicted. These are no calibration of the model to industrial data. The model was only calibrated to our lab test, which we needed 1 kilo of sample. We ran the test and we calibrated. Now, my colleague Marco actually gone much further. He developed the model into bins and a stockpile. We can pretty much simulate any type of geometry in a stockpile. If you got support system in a stockpile, we can incorporate them and we can simulate essentially how the material behaves. This is exactly we did for Mahalakoena as an example. Bins with any type of geometry, we can pretty much simulate those as well because we can incorporate that. Like bins, this is the typical Cadia bins that actually you got large bins with multiple draw points. We can simulate how the segregation happens. This one actually is very interesting for me because we have been discussing that for many years with Newcrest in terms of this is the effect of size segregation and how it's going to affect you. And last week, this week actually, we had a talk with the Cadia team, and we are working now toward using this model for them, which is basically shows how patient we are for many years to work to get to that point. And when you have 3 pairs, we can actually simulate that. The latest industry example that we did, Marco actually made in that form because they had a 3 pair. You can actually start strategizing the movement of your 3 pair to make sure that you minimize size segregation. Just remind you that this color coding is based on the size, average PAT. So we can actually track size segregation. The model runs significantly faster than real time. So you can actually use it for prediction, but you can run it real time as well. You can run it as soft sensor. And I think that model has the capability to start unlock the ore tracking, which means that we can preserve many of the geological information and we can track them throughout to the processing plant. And now we are getting more attraction from the industry that they want to use that practice to go through that direction. So one slide that I want to stop here, 2 slides essentially. I think one other thing that we have to be conscious of is all of these advances that is happening now. So there are new opportunities for us, if you look into the future as well, to get information from sources that previously it wasn't possible. So like many of these mobile sensors, like now spot actually is pretty much exists in many of the mining companies. I know Osmineral actually tested it in the underground. There are many groups actually they use it for safety inspection. You can actually literally have a sensor that is mobile. They can go to places and measure things. It's not like fixed. Drone have the same thing. They can provide you with a holistic view. In fact, we are working to use it as kind of one of our input to our stockpile model. You got variable technologies that you can benefit from that to provide some information. And also the future of visualization also is transforming as well. And I think this is something that we have to take into account. The traditional way of presenting our data and interacting with the plan is not attractive anymore, and it's not efficient as well. But these technologies, they are very well advanced now. They are in hand. They are not very expensive. I got the HoloLens basically two recently for almost 7,000. We had a hologram table in JK around 200,000. And you can actually start using these technologies. Become very cheap, accessible, and they're very efficient in terms of working. In fact, I have a PhD student now that actually it created, and I can use this word very comfortably now, created a true digital twin of our lab mill that you can actually literally put it into your office, turn it on, and it turns on the mill in the lab as well. And you can turn it off, it turns off. You can get the sound and everything with the technology here. And I think we can transform the future in terms of how operators would interact with the plant and make these remote operations more attractive as well. So these are the things that we have to look after as well, I think, and keep it in mind. Sorry, I think I didn't left any time, so it's only 1 minute left, but it's over to you, so Malcolm.
All right, thanks, Mohsen. You saw a few photographs of Mohsen in action in control rooms and things. So he speaks from personal experience. He's done a lot of work in control rooms. We've sat together controlling mills. We've got our personal record together of controlling a mill at 20.5 megawatts plus or minus 0.2 for 3 hours or something, autogenous mill. So a great and a different overview to most probably what you expected, which is what was really has been interesting about Mohsen's approach. It's not just a bunch of models, it's how do you use them in a framework that'll enable the uptake and kind of empower the industry that way. So do you have any questions?
Malcolm?
Yep.
Yes.
Hi, it's Tony here. Just a quick comment. This is really fantastic, Mohsen. Thank you. I know we've been talking about automation and the use, but for me, the most graphical message you have given today is how the information goes from the seconds to the years, and how the people who actually need to make the decisions are getting the wrong end of the information. And sometimes I actually wonder if some of your soft sensors could track floatable or recoverable tails as it moves through the plant. What other efforts that can aggregate to get this thing done? And this is really worth my time. Thank you very much. I appreciate the presentation.
I see Dave Deglon, you've got a question.
Yes, go ahead.
Yeah, I don't have a question, just a comment. I thought it's a fantastic presentation. Thanks very much, Mohsen. I was just wondering if you have time, whether you're prepared to stay on for another 10 minutes after this, together with Tony and Malcolm and Mohsen and Jeremy, I think the core members of the GCC, just to talk about P9R for 5-10 minutes, and Malcolm. That's possible.
No, I don't have anything in my calendar tonight, so I can make myself available, yes.
Great, thanks. Malcolm, are you able to, and Magnus and Tony and Jeremy?
If I hold off
I'm available
for a bit longer.
Yes, I'm available.
Yes,
Okay.
Yes, Dave, thank you. I'll stay.
All right, thanks.
I'll just pipe up quickly and then let you guys go. Yeah, really great presentation. Thanks. Like Tony said, that those first few slides on how you talk through the time that the groups have to make decisions, really insightful, and again also like the thinking on how we change that. The other thing that really resonated with me and more that you see was free non-coded software is the use of or the overuse of statistics for data. And just recently someone presented a model to us with more than 15 parameters and just no insight or input. So yeah, really great thing to touch on and to really drive home that, yeah, we need to use this in a meaningful way and still link it back to the fundamentals for it to retain that meaning. And yeah, just really great presentation. So thank you. Yeah, definitely worth staying back late for. I'll let you go. Thanks. Cheers.
Yeah, thank you very much, Bridget. Thanks.
Yeah, I think it is a critical area that Mohsen's picked up on there, that we don't throw away our knowledge to implement in AI. You use it to grow on and supplement the knowledge. So we're not going to be out of a job as mineral processors. Our job becomes even more valuable because we have to better define and put the knowledge in a form that these systems can utilize them and build off them to help make decisions.
Right.
Absolutely. Okay, cheers guys, thank you.
Thanks, Bridget.
Any other questions for Mohsen? So people have to go. Okay. Well, thanks, Mohsen. Really interesting. We'll have in a month's time, Marcelo Tavares is going to present 30th of March. So we look forward to that. Julia, I'll keep you updated on the ones coming up. And remember, they're open seminars. Invite your friends, get them onto the mailing list. So if you reply to this invite, Julia will add more people to the mailing list. So our room isn't full yet. So we welcome more people. And thanks for your time, Mohsen. It was really valuable.
No, thank you very much. Thanks for helping and organizing it as well. And thanks everybody for staying back and listening to me. It was very good.
Right. Cheers, everyone.
Yeah, thank you, Mohsen.
Bye. And thanks to Lee as well for organizing it. Thank you very much.
Yeah, thank you.
Thank you, Mohsen.
Thanks, Magnus. Are we going to stay in the same meeting for that one, or is